On October the 29th to 25, the skies were quiet, carrying on with the silent celestial motions they have held for billions of years. But in observatories across the Earth, astronomers were watching something that would break that quiet, something that would rewrite our understanding of the universe. They were watching a visitor, a traveller from another star system, a comet named 3I Atlas. This interstellar object was already a marvel, a rare guest from the void between the stars. But on this day it did something impossible. With no warning, its light began to flare. It didn't just get a little brighter. It surged intensely until it was shining with 5 times the brightness it had just hours before. This was not the gentle, gradual brightening of a comet approaching the sun. This was a sudden, unnatural, and completely unprecedented event. We understand why comets get bright. They are ancient travellers, time capsules made of ice, dust, and rock, left over from the formation of stars. As they travel through a solar system, the warmth from a star like our sun begins to heat them. This warmth doesn't melt the ice, it causes it to turn directly into a gas. We call this process sublimation. This gas erupts from the comet's surface, bursting out into the vacuum of space, and it carries with it a cloud of dust. This glowing fog of gas and dust is what we see. It's called the coma, and it's what makes a comet look like a fuzzy star, often with a beautiful tail streaming behind it. So the rule is simple: a brighter comet means more gas and dust. It means the comet is losing mass, shedding a piece of itself into space. When 3I Atlas flared to 5 times its brightness, the calculation was immediate and shocking. To produce that much light, it must have suddenly and violently ejected a truly enormous amount of material. The calculation suggested it would have had to lose about 13% of its entire mass. Imagine a mountain instantly shedding 1/8 of its rock and ice. This event should have produced a vast, spectacular cloud of gas, a signature so large it would be impossible to miss. Every telescope that could be pointed at the comet was. They stared into the dark, scanning the space around that impossibly bright point of light. They were searching for the cloud. They were searching for the gas and the dust that must be there. And they found nothing. There was no cloud, no gas, no dust. The comet was intensely bright, but the material that was supposed to be making it bright was simply gone. Or rather, it had never been there at all. It was a profound paradox. It was as if a bonfire had suddenly begun to rage 5 times hotter, all while using no wood. It defied the most basic fundamental law of comets. Across the astronomical community, a single baffling question began to be asked. Where did all that matter go? The universe, it seemed, was not finished presenting puzzles, as scientists were grappling with the impossibility of 3I Atlas. Their attention was pulled to another separate mystery. This one had unfolded just 3 weeks earlier, involving a different comet. This comet was named C25K on Atlas. This second-trip traveller was not an interstellar guest. It was one of our own, born in the vast frozen backyard of our solar system, a theoretical sphere of icy bodies called the Oort cloud. This comet, C225K, was a special kind of object. It was a sun grazer. Its long looping orbit brought it on a daring, dangerous path, not just near the sun, but skimming perilously close to its fiery surface. Its date with the sun was October 8th. For a fragile comet made of ice and dust, such a journey is almost always a final one. The crushing gravitational forces and the unimaginably intense heat of the sun are a death sentence. Comets that fly this close are expected to disintegrate, to be torn apart and vaporized completely. But C225K1 did not die. Against all predictions, it miraculously survived its fiery passage. It swung around the sun and emerged back into open space, scarred but whole, and it had changed. It was transformed. As astronomers watched it move away, they noticed it was glowing with a light they had never seen from a comet before. It wasn't the familiar pale, ghostly glow. It was a strange, distinct and beautiful golden light. The colour of a comet is its fingerprint. It is a chemical signature that tells us exactly what it is made of. Almost every comet we have ever studied has a characteristic glow. The head, the coma, is almost always green. Often there are hints of blue in the tail. This green colour is not a mystery. It comes from the gas cloud. When sunlight strikes the molecules in the coma, it energizes them and they glow. That familiar green light comes from a molecule called diatomic carbon, 2 carbon atoms bound together. The blue light comes from cyanogen, a molecule of carbon and nitrogen. These carbon-based molecules are the fundamental expected building blocks of comets. They are normal. The light from C25K1 was not normal. When astronomers used their instruments to analyze its strange golden light, the chemical fingerprint they read was all wrong. the comet was profoundly shockingly depleted of those carbon molecules. The very things that should have been there, the molecules that are supposed to make a comet green, were almost completely absent. This was extraordinarily rare. In the entire history of modern astronomy, only 2 other comets had ever been recorded with such a severe lack of carbon. This bizarre chemistry explained why it wasn't green, but it didn't explain the new golden light it had adopted. It was a survivor, glowing with a chemical signature that should not exist. And so by the end of October 2025, the scientific community was faced with 2 impossible objects. First there was 3i Atlas, the interstellar visitor. It flared to 5 times its brightness without losing any mass, an event that defied the laws of physics. Second, there was C-225 K1 Atlas, the hometown survivor. It flew through the sun's fire and emerged not as dust but as a changed object glowing with a wrong chemical light. 2 comets, both discovered by the same astronomical survey and so both sharing the name Atlas. 2 events separated by only 3 weeks. Each puzzle on its own was a profound mystery, but happening so close together, they felt like something more. They were not small errors in our data, they were deep fundamental contradictions. They were challenging our most basic models of the universe, and it was clear that the old rules no longer applied. But just as the world as humanity collectively turned its eyes towards this new visitor, something deeply terrestrial and frustratingly mundane happened. The data stopped. Here on Earth, in the United States, a government shutdown occurred. A disagreement over budgets and policies, a ritual of human politics, caused the flow of information to seize up. It's a strange thought, isn't it, that the exploration of the cosmos, the tracking of celestial bodies, could be paused by an argument about earthly finances. The major data streams from NASA, the eyes and ears that so many astronomers around the world rely on, went quiet. The telescopes were still pointed at the sky, but the data processing, the distribution, the teams that analyze it, they were paused. And so for a crucial period, as this object designated 3i/Atlas continued its silent journey, our most powerful instruments were effectively blind. In this sudden artificial darkness, this information vacuum, speculation and politics began to rush in. There were of course immediate demands for transparency. In the US, Congress Representative Anna Paulina Luna lodged a formal request. The public, now aware of this strange object, wanted to know what was being hidden. The official bodies, like the All-Domain Anomaly Resolution Office, known as ARO, issued a statement. Their position was swift and clear. This object was a comet. It was not, they emphasized, a UAP or an unidentified anomalous phenomenon. It was a natural occurrence. This classification, made so quickly, seemed designed to calm the public, to categorize the unknown and file it away. But for many it felt premature. To declare something natural before the primary observation campaign had even begun, it didn't quiet the questions, it only made them louder. This is where the mind of someone like Professor Avi Loeb finds its focus. He spoke about the concept of the black swan. A black swan event is an outlier, something that lies beyond the realm of our normal expectations. It's an event that is a complete surprise, but which after the fact seems almost inevitable. Loeb's perspective was one of careful scientific agnosticism. He did not claim that 3i/Atlas was artificial. He simply stated that the universe is vast, and while it is probably natural, the anomalies we were seeing were significant enough that we must not close the door on other possibilities. To immediately label it a comet just because comets are the most common explanation is a failure of the scientific imagination. When you find something truly strange, you must not default to the most familiar answer. You must instead gather more data. You must remain open to the possibility that you are seeing something for the first time. And so the world had to wait. The scientific community, patient and methodical, prepared for the real observation campaign. The International Asteroid Warning Network, or IAWN, coordinated a global effort. They designated a specific 2-month window from November 27th to January 27th. During this time, as the object moved further away from the sun, telescopes all around the world, both on the ground and in space, would be dedicated to observing it. But before that window even opened, the sky gave us a companion piece, a different show. On November the 24th, just a few days before the campaign was set to begin, another comet made its closest approach to Earth. This one was called Comet 2025 K1. This Comet K1 was everything a comet should be. It was bright, fuzzy and predictable. It displayed a beautiful tail of gas and dust as the sun warmed its icy heart. It was a classic, familiar, comforting sight. It was a perfect example of a natural visitor from the cold depths of our own solar system, and it served as a perfect control, a baseline for what normal looked like. As we watched this beautiful conventional comet pass by, it only highlighted the strangeness of the other one, the one that was quiet, the one that didn't have a tail. Then the shutdown ended. The data streams reopened, the IAWN campaign began, and the information that came in, it was more remarkable than anyone had anticipated. The anomaly wasn't just a rumour, it was real. The new data confirmed that 3I/Atlas was pushing itself. This is a concept known in astronomy as non-gravitational acceleration. Think of it this way: the Sun is the great anchor of our solar system. Its immense gravity dictates the path of every planet, every asteroid, every comet. Everything follows a precise, predictable orbit pulled only by gravity. If an object deviates from that path, if it speeds up or slows down more than gravity allows, something else must be acting on it. For a comet, this is expected. As it nears the Sun, the ice on its surface turns directly into gas erupting in powerful jets. These jets act like tiny, chaotic rocket engines. They sputter and burst, pushing the comet around. But the key word is chaotic. A jet might fire from one side, pushing the comet up, out of its orbital plane. Another might fire from the front, slowing it down. The acceleration is random, messy, and inconsistent. It's the behavior of a natural melting object. The acceleration measured from 3I/Atlas was not that. It was not chaotic. It was not messy. It was smooth, it was consistent, and most profoundly, it was precise. The analysis showed that the mysterious force pushing this object was acting exactly within its orbital plane. It wasn't being pushed up or down. It was being pushed in two specific directions: a radial force pushing it slightly toward or away from the Sun, and a transverse force pushing it forward along its path. This is not how a comet's gas jets work. This is how an engine works. A transverse force is what you use to speed up or slow down. A radial force is what you use to fine-tune your orbit to turn in space. To have both of these forces acting in perfect controlled concert purely within the orbital plane is optimized. It is the signature of a controlled low-power continuous thrust. It looked for all the world like a propulsion system. This discovery alone was staggering. It sent a quiet shockwave through the astronomical community, but it was the timing of this discovery that truly changed the nature of the mystery. Scientists, of course, did what they always do. They looked back, they re-examined all the old data, the observations taken before the object reached the Sun. They looked at the tracking data from July, from August, and from September as it was coasting in from interstellar space. And they found nothing. From July to September, the non-gravitational acceleration on 3I/Atlas was zero. It was completely null. It was a perfectly inert object. It was a dead rock drifting silently, behaving exactly as it should, pulled only by the laws of gravity. Then it passed perihelion. It made its tight, fast turn around the Sun in October. And then after it had completed that maneuver, after it was safely on its way back out of the solar system, the thrust appeared. The data went from zero to a small but constant, precise push. It wasn't a gradual warming. It wasn't a sputtering of jets that finally burst. It was as if something had been switched on. Now, let us rest for a moment on this object, this visitor 3I/Atlas. We have seen its journey, a strange and lonely path from a place we cannot name. We have watched it appear in our skies, a faint ghost, and then watched it shatter, dissolving back into the void. But the story does not end with its destruction. In fact, that is where the deepest mystery begins. When an object like this disintegrates, it offers us a gift. It breaks apart its own heart and spills its secrets into the light. Our telescopes, our spectrographs become instruments of archaeology. We are no longer just looking at the object, we are looking inside it. We are reading the ingredient list of its very being. And the ingredient list of 3I/Atlas was wrong. It was not just a little wrong, it was fundamentally, profoundly wrong. It was as if we had found a rock that bled, or a cloud that was made of solid iron. The data that came back from the telescopes simply did not align with anything we had come to expect from a natural visitor from the outer dark. Let us begin with its basic chemistry. When we look at a comet or any object in our solar system, we are looking at a chemical recipe. That recipe is governed by the laws of cosmic abundance. Iron is common born in the hearts of dying giant stars. Nickel is also created in stars, but it is far less abundant than iron. In virtually every natural object we have ever found in meteorites that fall to Earth, in the dust of asteroids, in the soil of Mars, there is always more iron than nickel. This is a fundamental rule of our solar system's construction. 3I/Atlas broke this rule. As the fragments of the object vaporized, our instruments read the light. The signature was unmistakable. There was more nickel than iron. This is not just a small curiosity. This is a profound puzzle. Finding more nickel than iron in a natural object is like dipping a cup into the ocean and having it come up full of pure fresh drinking water. It is a reversal of the expected order. This kind of ratio, more nickel than iron, is not something we see in nature, but it is something we see in our own workshops. We create alloys like this. We refine metals and mix them in specific unnatural ratios to create materials with special properties like stainless steel. To find this ratio in a supposed piece of ancient, pristine solar system debris is, to put it mildly, deeply confusing. But the strangeness was just beginning. It was as if we had opened a door to a strange room, and this was only the first impossible thing we saw. The next measurement was even more bizarre. We often look for the signature of cyanide in comets. It sounds alarming, but it is actually a very common molecule, a simple building block of carbon and nitrogen. It is a fundamental part of the primordial soup. We use it as a baseline, a way to measure the abundance of other, more exotic materials. It is the control sample in the experiment. So scientists looked for the ratio of nickel to cyanide. This would tell them how the metals compared to the simple common ice. What they found shattered all expectations. The ratio of nickel to cyanide was higher than any comet ever measured. Not just a little higher. It was in the language of astronomers, orders of magnitude higher. This is a phrase we hear in science, but its power is often lost. It does not mean 10% more or 20% more. 1 order of magnitude means 10 times more. 2 orders of magnitude means 100 times more. 3 orders of the magnitude, 1,000 times more. The signal for nickel relative to the common baseline of cyanide was screamingly loud. It was a shout in a library. It was a bonfire in a dark field. The object was not just rich in nickel, it was impossibly rich in nickel. Or perhaps it was impossibly poor in cyanide. Either way, the chemical recipe was unlike anything natural or modelled that we had ever seen before. So we have a visitor with a metallic signature that looks more industrial than natural. And we have a chemical ratio that is off the charts by a factor of hundreds or thousands. What else? This is perhaps the most glaring contradiction of all. The very definition of a comet. Why do comets have tails? They have tails because they are, as we've often heard, dirty snowballs. They are conglomerates of ice water, ice carbon dioxide, ice nitrogen, ice mixed with dust and rock. They are born in the freezing cold, far, far from the sun. When their long orbit brings them into the inner solar system, the sun's warmth begins to act on them. The ice turns directly into gas, a process called sublimation. This gas erupts from the comet's surface, dragging dust with it, and streams out behind the comet, pushed by the solar wind and the pressure of sunlight itself. This is the tail. The tail is the comet activated. Without ice, there is no gas. Without gas, there is no tail. An object without ice is not a comet. We call it an asteroid. It is a simple fundamental distinction. 3I Atlas had a tail. We all saw it. It was photographed, measured, and classified as a comet precisely because it had a tail. It was shedding gas and dust as it approached the sun. But when scientists measured the composition of that tail, when they looked for the primary ingredient that should have been there, they found almost nothing. The amount of water detected was minuscule. The object was not a snowball. The final calculation suggested its composition was at most 4% water. 4%. This is not a dirty snowball, this is a dirty rock. It was as dry as an asteroid. So we are left with a paradox that sits at the very heart of this object. It behaved like a comet, but it was made like an asteroid. It produced a vast, brilliant tail, but it was made of materials that should not create a tail. It was a thing that should not exist. A dry comet, a rock that shed its skin. Each of these 3 anomalies, the nickel-iron ratio, the nickel-cyanide ratio, and the profound lack of water, is a mystery in its own right. Any one of them would have been enough to make 3I Atlas a famous and puzzling object, the subject of scientific papers for a decade. But they all happened together in the same object, and this was not all. When the chemical data was fully analysed, the astronomers studying the object turned to another set of data. Not what the object was made of, but how it interacted with light. We have spoken of polarization. It is a simple, beautiful property of light. Sunlight is unpolarized. The light waves vibrate in all directions at once. But when that light bounces off a surface, the hood of a car, the surface of a lake, or a cloud of dust particles in space, it gets combed. The reflections tend to vibrate more in one direction than another. This is polarization. Our sunglasses use this principle to cut down on glare. Astronomers use it to understand the texture and composition of the dust they are looking at. Different shapes, different sizes, and different materials will polarize light in different, predictable ways. For decades, we have pointed our instruments at comets, and we have built up a vast library of how their dust polarizes sunlight. There is a standard model of comet dust. It is reliable, it works. The light reflected from the dust of 3I Atlas did not just fail to fit the model, it broke the model. It exhibited what is called extreme negative polarization. This is a technical term, but what it means is simple. The light was polarized in a way that was not just unusual, but was in a range that our models of natural comet dust suggested was almost impossible. The light was being combed in a way that defied our explanations. The scientists who published this data ran the numbers. They calculated the probability. What is the chance that a cloud of dust composed of naturally occurring particles would produce the specific signature that they measured? The answer they found was less than 1%. This was not a subtle finding. The data was clear. The object's dust was spooky, as one astronomer put it. It was behaving in a way that no natural comet dust ever had. It was a statistical impossibility, a fingerprint from an unknown hand. So let us pause now here in the quiet. Let us take a slow, deep breath, and let us look at the pieces we have assembled. We have an object, a visitor. 1. It has a metallic composition that looks more like a refined industrial alloy than a natural rock with more nickel than iron. 2. It has a chemical ratio of nickel to cyanide that is hundreds, perhaps thousands of times different from any comet we have ever seen. 3. It behaved like a comet producing a glorious tail, and yet it was as dry as an asteroid or a star, missing the one ingredient, water, that is required to make a tail. 4. The dust in that tail reflected light in a way that is statistically almost impossible, with a probability of less than 1% of being produced by any natural dust we have ever modelled. This is the heart of the argument. This is the stacking of the probabilities. When you are faced with a single strange event, it is easy to dismiss it. You can find a way to explain it. Perhaps you might say there is a very rare type of asteroid, a fragment from a planetary core that is rich in nickel and poor in iron. And perhaps this fragment just happened to fly through our solar system, a 1 in a million shot but possible. And perhaps you could say this object on its journey had all of its surface ice burned away by a close pass to another star, leaving it dry. Unlikely, but not impossible. And perhaps you could say there is a whole new class of interstellar dust particle that we have never dreamed of, and this dust just happens to polarize light in this spooky negative way. It would be a major discovery, but it is a possible explanation. Each anomaly taken by itself can be given a natural explanation. Each one is a tiny, tiny probability, a rare but possible event. The question is not about any single piece of evidence. The question is, what is the probability of all of them happening at the same time in the same object? This is where logic and intuition collide. We must multiply the probabilities. We must take that 1 in a million chance and multiply it by the other 1 in a million chance, and multiply it again and again. The final number, the probability that one single natural object would by pure chance happen to have all 4 of these deeply strange, almost impossible characteristics. That number becomes vanishingly small. It becomes a number so close to 0 that it tests the limits of our belief. We are left in a quiet, contemplative and perhaps uncomfortable place. We are faced with a choice. Do we accept that we have just witnessed a miracle? A true 1 in a billion natural object, a cosmic coincidence so profound it may never be seen again? Or do we begin to consider the only other alternative, the alternative that is in its own way just as profound and just as unsettling, that this object was not natural at all? This is the hypothesis that lingers in the silence. The idea that 3I Atlas was not a product of cosmic chance, but a product of intention, and that as we continue our journey is the path we must, however, carefully begin to walk. If the mysteries of 3I Atlas stopped with its shape, its light and its composition, it would already be the object of the century. But as we continue our journey, as we pull back to look at the bigger picture, the puzzle only deepens. The strangest clues are not just about what it is, but where it came from and the path it took to get here. This new chapter of the enigma is about its orbit. To understand why its path is so strange, let's picture our solar system. For all its vastness, it is incredibly organized. Think of it as a flat disk, like an old vinyl record or the still flat surface of a pond. All the planets from Mercury out to Neptune circle the Sun on this same flat plane. We call this the ecliptic, and they all travel in the same direction, spinning together in a vast shared dance. Now an object from interstellar space, a visitor. It wouldn't know about our rules, it wouldn't know about our flat plane. These objects are born from other stars, from random events, from the chaos of the galaxy. We expect them to arrive from any direction at all. Most comets from our own Oort cloud come in at steep angles, plunging down from above the disk or rising up from below. This is what random looks like. But 3I Atlas did not do this. It arrived against all expectations almost perfectly parallel to our flat ecliptic plane. It slid into our solar system as if it knew the rules, aligning itself with the very disk on which all our planets live. This by itself is unusual, but it's the next detail that stunned astronomers. While it was on the correct plane, it was going the wrong way. It's on what we call a retrograde orbit. Every planet, every asteroid, every piece of local dust is flowing in one direction, and 3I Atlas is pushing back against the tide. It is driving the wrong way down the cosmic highway. Let's hold these two facts together. It is both aligned with the flat plane of the planets and going in the exact opposite direction. How rare is this? The calculated probability of an interstellar object having this specific bizarre combination of traits just by pure chance is about 0.2%, 0.2%. It's an orbital path that seems designed to be noticed, a statistical outlier that screams for our attention. But the orbit is only the first part of this timing puzzle. The second part is when it arrived. Its path was strange. Its timing was suspicious. An object this large, this bright, this reflective, it should have been visible to us. As it made its closest approach to the sun, what we call its perihelion, it would have been at its most brilliant. It would have been a spectacular sight, a gift to astronomers, and yet we missed it. We missed the most important moment. Why? Because at the exact moment of its closest, brightest approach, 3I Atlas was positioned perfectly behind the sun. From our vantage point on Earth, it was completely invisible, hidden by the blinding glare of our own star. Its orbit didn't just bring it near the sun, it was a grand tour. The trajectory brought it close to Mars. It had encounters with Venus. It swung by the giant Jupiter. It danced through the most populated part of our solar system, interacting with almost every major planet. And yet at the one moment it should have been most obvious, it was veiled. It was a cosmic performance with the curtains drawn, a guest who arrives at the party but hides just out of sight. Professor Avi Loeb, a scientist who is no stranger to controversial interstellar objects, performed the calculation. He asked, what is the probability of all of this happening? By chance, what are the odds that a random object from space would have this precise retrograde but flat orbit and have its perihelion, its closest approach, timed so perfectly that it is hidden from Earth by the sun? The number his team arrived at is almost too small to comprehend. 0.01%. One chance in 20,000. In science, we live on probabilities. A 1 in 100 chance is rare. A 1 in 1,000 chance is remarkable. A 1 in 20,000 chance is not just remarkable. It is a profound statistical challenge. It forces us to ask a difficult question. When does a coincidence become so unlikely that it ceases to be a coincidence? When must we start to wonder if the path was not random at all, but intentional? This is not a question science likes to ask, so we must do what science does best: we test. We try to prove the natural explanation. Let's go back to the most popular normal idea that 3I Atlas is a piece of a comet. That it exploded, broke apart, and lost, as the calculations suggest, 13% of its entire mass. If that happened, if a mountain-sized object violently shed 13% of itself in a single catastrophic event, it would not be a clean break. Such an explosion would release a truly staggering cloud of gas and dust. That material, all that missing mass, would be blown into space. It wouldn't just disappear. It would form a vast, diffuse but detectable cloud. This cloud, this ghost of the explosion, would be travelling along with the object. So here is the test. A test so simple and so profound that it could end the debate. An upcoming observation campaign is planned. The most powerful telescopes on Earth and in space will be aimed at 3I Atlas. But they won't just look at it. They will look around it. They will hunt for this cloud. They will search for the chemical fingerprints of that missing 13%. The stakes could not be higher. If they find the cloud, if they detect the gas, the mystery may be solved. 3I Atlas would be confirmed as a comet, albeit the strangest comet humanity has ever witnessed. It would still be a statistical miracle, but it would be a natural miracle. But what if they look and there is nothing? What if the space around 3I Atlas is empty, clean? What if that 13% of mass is nowhere to be found? If the cloud is not there, the hypothesis fails. The natural explanation, the one that holds all of these other strange facts together, completely collapses. We would be left with an object that lost a huge part of itself without a trace. We would be back at the very beginning, but this time stripped of our most logical answer. The failure of this test would be in itself the most shocking discovery of all. As we wait for that day of reckoning, the data we already have continues to stack anomaly upon anomaly. And the next one is a paradox of simple physics. It concerns the object's size and its speed. We have already touched on its size. This is not a small rock. This is not Oumuamua, which was perhaps the size of a skyscraper. 3I Atlas, based on its brightness, is a giant. The estimates are staggering. It is thought to be perhaps 1 million times more massive than Oumuamua. 1 million. It is a colossus, a true behemoth coasting silently through our planetary home. So it is huge. Now let's look at its speed. It is moving incredibly fast. It is not just fast for a comet, it is fast for anything in our galactic neighbourhood. Its velocity is so high that it places it in a very exclusive club. The probability of any random object pulled from the Oort cloud or from a neighbouring star having this specific speed is less than 0.1%. Now hold those two facts in your mind at the same time. It is one of the biggest objects we've ever seen visit, and it is one of the fastest objects we've ever seen visit. This combination is a deep, deep puzzle. In physics, there is a trade-off. To make something big move fast requires a truly enormous amount of energy, a force of unimaginable power. Small things like dust particles can be accelerated easily. But this is like trying to make a mountain win a sprint. Where did it get this energy? What cosmic engine could have given this giant such a powerful push? Was it born in the heart of a supernova? Was it slingshotted by a black hole? The natural explanations we have for this kind of acceleration are all themselves catastrophes, events of cosmic violence, and yet the object itself appears pristine, a perfect mirrored surface. It is another special circumstance, another 1 in 1,000 data point added to the pile of other 1 in 1,000 data points. It is too big and too fast to be easily explained, and still the universe was not done surprising us. Perhaps the most baffling, most physics-defying observation came from the Hubble Space Telescope. In July and August, as this strange visitor was on its way out, Hubble was tasked with watching it, and it saw something that by all rights should not exist. It saw a jet of material spraying towards the sun. Let's be very clear about why this is so impossible. Comets have jets, that part is normal. As they get near the sun, the ice turns to gas and shoots off pushed by the heat. But this creates a tail, and that tail has one simple unbroken rule: it always points away from the sun. The sun is constantly breathing out a stream of particles called the solar wind. This wind is powerful. It acts like a cosmic breeze pushing all gas and fine dust away from it. A comet's tail is like a flag in that wind. It must flow downstream. It cannot under any circumstances fly back into the wind, but Hubble saw it. In July and in August it captured images of a jet of matter, a distinct stream originating from 3I Atlas and flowing directly against the solar wind back towards the sun. This is not supposed to happen. It's like finding a river that flows uphill. It's like watching smoke pour down into a fire. Scientists whose job it is to find rational explanations scrambled. They proposed, perhaps the object has a very strange, complex terrain. Perhaps a deep canyon or a strange mountain on its surface could, if the object is also spinning and tumbling in a very precise way, vent gas at a strange angle. Maybe this angle combined with our perspective just looks like it's going backwards. It is possible, it is a line of reasoning, but it is also once again a special, unique and highly specific circumstance. And that is where we are left. That is the state of the mystery. We are faced with a list. An object with a shape that defies physics. An object that reflects light in a way nothing in nature does. An object that seems to have exploded but left no evidence. An object with a 1 in 20,000 orbit timed perfectly to hide from us. An object that is both gigantically large and impossibly fast. And an object that defies the laws of the sun, shooting jets the wrong way. The problem is not any one of these things. Science could perhaps explain one. Or even two. The problem is the pattern. The problem is the stacking. How many 1 in a million chances can we accept? How many special circumstances can we line up in a row before we are forced to consider that our most basic assumption, the assumption that this is a natural object, is the one thing that is wrong? We are staring into the dark at a visitor that has challenged everything we thought we knew, and the more we look, the less sense it makes. We are left staring into the darkness, puzzled by the void. We have just considered 3I/Atlas, the impossible visitor. The perfect black, the unnatural speed. It has raised questions that science is not equipped to answer easily. It has challenged our definitions of what is natural. But we must remember it is not the only mystery. It is not the only strange traveller to arrive in our neighbourhood. Our attention now turns back to the other one, the golden one, Comet C/2025K1. This was the first object that made us pause. The one that by its sheer unexpected beauty made the world look up. While 3I/Atlas was a creature of shadow, C/225K1 was a creature of light. A brilliant, defiant gold that did not match any comet we had ever recorded. And the mystery of the golden comet is not over. In fact, it continues to deepen long after it has passed its closest point to our Sun. A normal comet is a simple thing. It is a ball of ice and dust. As it gets close to the Sun, the heat boils the ice. This creates a magnificent tail and a fuzzy cloud around the comet, which we call a coma. This cloud is what catches the sunlight and makes the comet bright. The rule is simple: the closer to the Sun, the more heat, the more boiling, the brighter the comet. The reverse must also be true. As the comet swings back out away from the Sun back into the cold darkness of the outer solar system, the heat fades. The boiling slows down. The fuzzy cloud should shrink and the comet should get dimmer. It should fade week by week until it is just another faint speck disappearing back into the abyss from which it came. But C/225K1 is not doing this. It's not fading as expected. It has passed its closest approach. It is moving away from the Sun. By all our laws, its brightness should be dropping off rapidly, yet it remains stubbornly, persistently bright. Its golden coma is not shrinking. Its light is steady. It is like a fuzz that continues to burn brightly long after its fuel should have been spent. It is an echo that refuses to fade. Astronomers are perplexed. What is powering it? What is keeping this celestial engine running? A normal comet's activity is driven by water ice. But perhaps this comet is not normal. Perhaps its glow is powered by something else. Exotic ices like frozen carbon monoxide or nitrogen that can boil at much colder temperatures. But even then the activity should be decreasing. It isn't. It holds its light. It holds us its mystery. It hangs in our sky as a constant golden question mark. So now we have two anomalies. Two puzzles that arrived one after the other in the space of just a few months. Let us think about their names and their timing. Both of these objects, the black and the gold, were discovered by the same system. ATLAS, the Asteroid Terrestrial Impact Last Alert System. This is a set of robotic telescopes whose job is to scan the sky night after night looking for things that move. Its primary mission is to find asteroids that might pose a threat to Earth. It is our planetary defense system, our watchdog. And this watchdog, in the course of its nightly patrol, found both. First C/25K1, the golden comet that shone too brightly. Then just months later, 3I/Atlas, the interstellar object that was too fast and too dark. The universe is billions of years old. Our solar system is vast beyond comprehension. And in all our recorded history of watching the stars, we have never seen anything quite like either of these two objects. And they arrive at the same time. Is this a coincidence? Our minds are built to find patterns. It is how we survive. We see the pattern of the seasons and we know when to plant. We see the pattern of a tracks and we know to be afraid. We see patterns in the stars and we create stories, constellations and myths. Sometimes a pattern is just a coincidence. It is just our imagination connecting dots that have no real connection. If you flip a coin, it might land on heads 5 times in a row. It feels like a pattern. It feels significant. But it's just chance. So is this just chance? Is it just a random flip of the cosmic coin that two of the most bizarre objects ever witnessed decided to visit us in the same year, discovered by the same set of eyes? Or is it a pattern? Is this something more? Is the universe trying to tell us something? Is this a knock on the door? Not just one knock, but two. A rapid knock-knock. One in shadow, one in light. One impossibly fast, one stubbornly bright. Science by its very nature must first assume it is a coincidence. The job of science is to find the safe explanation. The explanation that does not require us to throw out everything we know. So let's be good scientists. Let's try to find the safe explanation. How could these two objects be perfectly natural even if they are strange? Let's start with 3I/Atlas, the interstellar ghost. The safe hypothesis is that it is just a very, very unusual piece of debris. Maybe it was an object like a comet or an asteroid that was formed in another solar system. As it travelled through the galaxy for millions or even billions of years, it passed through intense clouds of cosmic rays. Cosmic rays are high-energy particles, atoms moving at nearly the speed of light blasted out from exploding stars' supernovas. If you fly through a dense field of these particles for a very long time, the radiation will cook your surface. It will break down the molecules, boil away any light materials, and leave behind a thick crust of carbon. It's like leaving a piece of bread in a toaster for an hour. It becomes charred, black. So perhaps 3I/Atlas is just an ancient, well-travelled, and extremely burnt piece of interstellar rock. This radiation baking could have altered its surface so completely that it no longer reflects any light. This is a possible natural explanation. Now, what about the golden comet C/25K1? The safe explanation here is that it comes from a very, very specific place. We have the Oort cloud, that vast theoretical sphere of icy bodies surrounding our solar system trillions of miles away. But what if there are different regions of the Oort cloud? Perhaps C/225K1 comes from the most distant unexplored part, a region so far out that the recipe for making comets was different. Maybe the dust in that region was rich in unique minerals, giving it that strange golden colour. Maybe it's made of different ices, not just water, which explains why it continues to glow, even as it moves away from the sun. This is also possible. It doesn't break any laws of physics. It just requires that our solar system is even more varied and strange than we already thought. So there we have it, two safe explanations. The interstellar object was heavily irradiated by cosmic rays. The golden comet was formed in a rare special region of the Oort cloud. But there is a problem with these safe explanations. The problem is that they require too many special circumstances all lining up at once. It's what philosophers of science sometimes call the appeal to luck. Let's look at it again. For 3I/Atlas, you need a rare interstellar object. That's rare to begin with, then it must have travelled through an uncommonly dense field of cosmic rays. Then that radiation must have been just right to make it perfectly black instead of just dark. Then it has to be on a path that brings it right to us. And it has to be moving at a speed that seems to defy a simple gravitational slingshot. That is a lot of special conditions all in one package. For C/2025K1, you need a comet to be knocked out of the most distant hypothetical region of the Oort cloud. That's rare. It must have a chemical composition we have never seen before. Also rare. And it must have an internal structure that allows it to keep burning brightly, which is also unheard of. That too is a lot of special conditions. Each object on its own strains our models of what is normal. But now, you have to put them together. You have to accept that both of these incredibly rare 1 in a billion chance objects just happened to arrive in our solar system at the exact same time. This is the real problem. It is the piling of one coincidence on top of another. It's like walking outside and getting struck by lightning. That is an incredibly rare event. But it happens. It's a safe explanation. But what if you get struck by lightning and then 10 seconds later a meteorite lands at your feet? You could still say it's a coincidence. Both events are possible. But at some point you would have to start wondering if the universe is trying to get your attention. When does an explanation become so complicated that it is no longer the simplest answer? This leads us to a difficult place. A place of deep philosophical tension in the heart of science. We can call it the black swan trap. For centuries in the Western world, it was an absolute undisputed fact that all swans were white. Every swan ever seen, every swan in every story was white. All swans are white was a perfect example of a scientific truth proven by thousands of observations. And then explorers travelled to Australia and they found black swans. In an instant, a single observation destroyed a truth that had stood for 1,000 years. The impossible was suddenly real. A black swan event is something that is completely outside the realm of normal expectations. It is something that is considered impossible until it happens. The trap is this science is built on skepticism. A scientist's job is to be the person who, when shown a black bird that looks like a swan, says, "Prove it, it's probably just a goose, or maybe it is a white swan covered in mud." This skepticism is essential. It is the immune system of reason. It protects us from bias, from wishful thinking, from magic. But what happens when that skepticism becomes a form of blindness? What happens when we are so determined to prove that the blackbird must be a dirty white swan that we refuse to see what is right in front of us? Are we right now caught in a black swan trap? We are looking at two objects in our sky. We are trying very, very hard to explain them as dirty white swans. We are building complicated stories about cosmic rays and special Oort clouds to make them fit our old models. Is our skepticism serving discovery, or is it preventing us from recognizing a new reality? It is the most difficult question a scientist can face. When do you stop trying to make the new data fit the old theory and accept that the theory itself might be wrong? We are cautious, we are hesitant, because the alternative, the black swan explanation, is simply too large to comprehend. And yet, there is one final detail, one last piece of the puzzle that we must in good conscience place on the table. It's a connection so strange, so chilling, that most astronomers are afraid to even whisper it. It connects our interstellar visitor 3I/Atlas to the single greatest mystery in the search for extraterrestrial intelligence. We must go back in time. The year is 1977, the month is August. At Ohio State University there is a radio telescope called the Big Ear. It is not a sleek modern dish. It is a massive sprawling field of metal the size of 3 football fields. Its job is not to take pictures but to listen. It is scanning the sky, listening for radio waves as part of the search for extraterrestrial intelligence, or SETI. It is listening for a hello. Astronomers had long theorized that if an alien civilization wanted to send a signal to announce their presence, they wouldn't just broadcast on any random frequency. They would choose a special one, a magic frequency that another intelligent species would recognize. The most famous candidate was the frequency of neutral hydrogen. This is the most common element in the universe. It emits a faint radio hiss at a very specific frequency, 1420 MHz. It is a fundamental universal constant. It is the sound of the universe itself. The Big Ear was listening to this channel. On the night of August 15th, the telescope was pointed at the constellation Sagittarius, and for 72 seconds it heard something. It was not a hiss, it was not static. It was a clear, strong, narrow-band signal. It was exactly the kind of signal a radio transmitter would make. It was 30 times stronger than the background noise of space. It was exactly on the hydrogen frequency. The signal appeared, grew stronger as the telescope moved over it, and then faded as the telescope moved away. It lasted for exactly 72 seconds, the precise amount of time it would take the telescope to drift past a fixed point in the sky. The astronomer reviewing the data logs days later was a man named Jerry Amon. He saw the string of numbers and letters representing the signal's incredible strength. He was so stunned he grabbed a red pen, circled the sequence, and wrote one word in the margin: "Wow." It became known as the wow signal. And then, silence. We pointed the Big Ear back to that spot. Nothing. We have used our most powerful modern telescopes to listen to that tiny patch of sky in Sagittarius. We have never heard it again. It was a single 72-second shout from the cosmos from an unknown source for an unknown reason. It remains the most compelling and most baffling candidate for an alien signal ever detected. It has never been explained. Now, let us return to the present day, to our dark messenger 3I/Atlas. When an interstellar object is found, the first thing we do is trace its path. We look at its trajectory, its speed, and we calculate where it came from. We trace its line of travel backward out of our solar system and across the galaxy. Where did 3I/Atlas come from? It came from the direction of the constellation Sagittarius. It came from the exact patch of sky where the wow signal was heard in 1977. The chances of a random interstellar object lining up with that one specific spot, the location of our most famous unexplained SETI signal, have been calculated. The probability is 0.6%, less than 1 in 100. Let us be very, very clear. This is not proof. We must say that again. This is not proof. A 1 in 100 chance is not 0. Unlikely things happen every single day. Someone wins the lottery. Lightning strikes the same place twice. It's possible that this is just another layer of staggering, mind-boggling coincidence. It is not evidence, it's not a conclusion. It is just another point of das. It is another strange fact to add to our growing list of strange facts. Let's review the list for our dark visitor. 1. It is interstellar. Rare. 2. It is moving at a speed that is almost impossible to explain by natural means. Extremely rare. 3. It is the blackest, least reflective object we have ever observed in our solar system. Unique. 4. It arrived at the exact same time as another, completely bizarre object, the Golden Comet. A staggering coincidence. 5. It came from the precise direction of the most significant, mysterious and unexplained alien signal in human history. A less than 1% chance. This is the point where the safe white swan explanations begin to collapse under their own weight. The tower of coincidences is getting too high. It is beginning to teeter. We are standing on a shore looking out at the ocean, and we have just seen 2 things crest the horizon. One is a ship of pure perfect black moving with impossible speed. The other is a ship of burning defiant gold which does not slow or fade. They are messengers, and we are left here on the shore with the cold wind on our faces, forced to ask the one question we have always been afraid to ask. What is the message? It is a path that science by its very nature is hesitant to walk. And rightly so. Science must be built on the solid ground of the probable, the testable, the known. It must always prefer the simplest explanation that fits the data. The Comet hypothesis, even with all its difficulties, is the simpler path. It relies on objects and processes we know exist. But here in the quiet of this moment, we are not limited by the rigid demands of a scientific paper. We are free to explore. We are free to follow the data, even if it leads us to a place that feels uncomfortable. We are free to conduct a thought experiment. Let us set aside the comet explanation just for a moment. Let us hold it gently and place it to one side. We will not discard it, but we will look at the other possibility. The one that the data seems to whisper, but which our scientific minds are trained to shout down. The inconvenient hypothesis. Let us imagine, just for a moment, that we are an incredibly advanced civilization. We are perhaps millions of years old. We have solved the challenges of our own star system. We are curious. We look out at the vast silent galaxy, and we wonder, are we alone? We decide to find out. But how? The distances are mind-boggling. To travel between the stars is not a journey of years, but of millennia. Sending living beings, fragile creatures of water and carbon, is an immense, perhaps an impossible challenge. So we decide to send a probe, a messenger, an emissary of our existence designed to travel the Great Gulf, to listen, to watch, and perhaps one day to report back. Let us try to design this probe. What would it be like? We are not building this to last for a 10-year mission like our Voyager probes. We are building this to last for eons. It must cross the void, perhaps drifting for 1 million years before it even arrives in a new promising solar system. So what material would we use? It would have to be incredibly durable. It will not be travelling through the protective bubble of an atmosphere. It will be in the hard vacuum of interstellar space. It will be subjected to the endless cutting sleet of micrometeorites, tiny grains of dust smaller than sand but travelling at tens of thousands of kilometres per hour, each impact a tiny explosion. It would also be soaked in cosmic radiation, high-energy particles from distant supernovas, from its own distant star, from the galaxy itself. This radiation tears apart delicate molecules. It degrades plastics. It fries electronics. So we would not build our probe from flimsy materials. We would build it from something tough, something that resists radiation, something that can withstand those tiny, relentless impacts. We would probably choose advanced metal alloys, perhaps alloys based on nickel or titanium. Strong, stable, resistant to the corrosion of the void. It would be dense, it would be solid, it would be built to endure. When we look at 3I Atlas, we find its composition is strange. It is not a fluffy, light, icy object. The data suggests it is dense. It suggests it is tough, cohesive, and made of materials that are hard to identify, but they are not the usual components of a comet. The first requirement of our thought experiment, it seems to fit. Now what about fuel? How would this probe travel? It has a billion-year journey. We cannot use the chemical rockets we use today. They are powerful, yes, but they burn their fuel in minutes. They are like a firework, a brief, brilliant burst. We do not need a firework. We need a candle. We need something that can burn faintly but steadily for an unimaginable length of time. Or perhaps we need something even more clever. Perhaps that the probe is designed to be efficient. It doesn't need to burn fuel all the time. It could use a solar sail unfurling a vast thin sheet to catch the light from stars, just as a sailboat catches the wind. It would accelerate slowly, oh so slowly, but over 1,000 years it would build up incredible speed. Or perhaps it uses a low-thrust engine like an ion drive that sips its fuel, accelerating tiny particles to enormous speeds, producing a thrust so gentle you could hold it in the palm of your hand. But this gentle push applied continuously for centuries would be enough. And when would this probe use its fuel? It wouldn't use it out in the deep, empty space between stars. That would be a waste. It would drift. It would fall through the galaxy, pulled by the gentle tide of gravity. But when it enters a new solar system, when it encounters a new star, that is when it might awaken. That is when it might need to maneuver. It would need to adjust its course, to slow down, to angle itself to observe the planets it finds. And so it might fire its small thrusters. Not a great visible plume like a comet, but a tiny, precise, almost invisible push, a non-gravitational acceleration that a distant observer would struggle to explain. This is exactly what we saw with 3I Atlas. It accelerated. It pushed itself off its natural gravity-defined path. But we saw no comet tail, we saw no outgassing, we saw no plume, we saw a push without a visible cause. The second part of our thought experiment, it also fits. It fits in a way that is clean and logical and deeply unsettling. Finally, let us consider the composition. The stuff the probe is made of. We have already decided it would be metal alloys. But what about water? What about the ices that make up a comet? A comet is a dirty snowball. It is mostly water ice. That is its defining feature. When it gets near the sun, that ice turns to gas, creating the beautiful tail that stretches for millions of kilometers. Our probe, our machine, would it be made of water? No. That makes no sense. It's a terrible building material for a starship, but could it have some water? Let us think. Perhaps the probe's engine, its ion drive, uses water as a propellant. It is a simple common molecule. You could split the water into hydrogen and oxygen and use them. Or you could use the water itself, accelerating the molecules. But you wouldn't need a lot of it, not compared to the probe's total mass. If your probe was a machine made of dense alloys and advanced systems, maybe its fuel, its water ice, would only make up a small part of its mass. How much? Perhaps 5%, perhaps 4%. The data from the telescope shut down. The data that was so puzzling suggested that 3A Atlas contained water, but only about 4%. 4%? For a comet, this number is an impossibility. It is a contradiction in terms. A comet with only 4% water is not a comet at all. It is like describing a bird with no feathers. It is like describing a fish that cannot swim. But for a probe, for a machine, 4% is reasonable. It's a plausible number. It is an amount of fuel or reaction mass that makes logical engineering sense. So now let us step back from our thought experiment. We have designed a hypothetical interstellar probe using only the laws of physics and engineering. We decided it would be made of durable, dense materials. We decided it would have a low-thrust efficient engine that it uses only when needed. We decided it would carry only a small practical amount of fuel, like water. And then we look at the data for 3I Atlas. It is dense and durable. It accelerates without a visible tail. It has a composition that includes only about 4% water. The description of our hypothetical probe matches the data from 3I Atlas. The description of a comet does not. This is the core of the inconvenient hypothesis. It is the moment where the data forces us to choose between an explanation that is comfortable but doesn't fit and an explanation that is extraordinary but does. It is not proof. A thought experiment is never proof, but it is a line of reasoning. And it is a line of reasoning that the scientific community in the fictional story of 3I Atlas found itself wrestling with mostly in private. Because what do you do with this? This brings us back to the silence. The strange quiet end to the 3I Atlas story. Let us look back at what happened. The telescope that made the discovery, it was shut down. The reason given was a hardware malfunction, a critical cooling failure. Was this just a coincidence? Was it just a convenient excuse? In the real world of science, instruments fail. It happens all the time. It is the most likely the simplest explanation. But in the context of this inconvenience, it feels timely. It stopped the flow of the most anomalous data. It quieted the conversation. And then there was the ARO statement, the All-Domain Anomaly Resolution Office. This is the office tasked by the government to investigate unidentified anomalous phenomena or UAPs. Their statement when rumours began to circulate was a masterpiece of careful wording. They stated they had no credible evidence that 3I Atlas was of extraterrestrial technological origin. But no credible evidence is not the same as it is not artificial. It is a legal political phrase. It means the data has not met an impossibly high bar of proof. It is a way of dismissing the question without actually answering it. It's a way of taking this profound, unsettling scientific anomaly and putting it back in the box. It puts it in the file labelled UFOs and conspiracy, which allows the mainstream serious world of science to breathe a sigh of relief. It allows them to get back to their work to focus on the comets and asteroids they do understand. The ARO statement was perhaps a way to make the inconvenient hypothesis invisible, to re-establish the comet narrative as the only respectable one even if it didn't fit the facts. This is the danger of a centralized story. When all the data comes from one source, or when the interpretation is controlled by a few voices, the narrative can be managed. The inconvenient can be filed away. This is why the final part of this story, the part that is still unfolding, is so important. The importance of independent verification. The universe is not observed by one eye. It is observed by millions. The data from that one now shuttered telescope was not the only data. The sky is vast, but it is not private. The International Asteroid Warning Network, the IAWN, is a real thing. It is a global collaboration of observatories, professional and amateur, tasked with finding and tracking objects that come near Earth. They exist to protect us, and to do that they share data. They are not one organization. They are a network, a web. They are in Chile and Hawaii and Spain and Arizona. Their data is decentralized. It is spread across servers all over the world. And then there are the amateurs. There are hundreds of thousands of amateur astronomers, people in their backyards in small local observatories with telescopes they built themselves. They are driven by pure passion, by a love for the night sky. They are not bound by committees. They do not need to apply for funding. They are independent. When 3i Atlas swept through our solar system, it was not just seen by one telescope, it was seen by many. The amateurs, they saw it. The IADUN, they tracked it. Their data, the data from these scattered independent eyes, cannot be controlled. It cannot be classified. It cannot be shut down by a cooling failure. It is out there. It is in the public domain. And that is the true, beautiful, and final safeguard of science. The data is messy, it is noisy. The data from a backyard telescope is not as clean as the data from a billion-dollar space observatory. But it is real. And right now, as we rest, as we drift, there are scientists and students and amateurs all over the world sitting at their computers. They are pulling this decentralized data. They are writing code, they are cleaning the images. They are comparing the observations from a telescope in Australia with one in New Mexico. They are quietly, independently verifying the story. They are not looking for aliens, they are just doing science. They are trying to find the truth. They are trying to understand the object that visited us. They are trying to make the data fit. They are building new models. What will they find? Perhaps they will find the flaw. Perhaps they will discover a new kind of comet, a nickel alloy comet, and our understanding of the solar system will change. Perhaps they will find a subtle error in the 4% water calculation. Or perhaps they will not. Perhaps as they clean the data, as they combine the observations, the signal will get stronger. Perhaps the anomalies will become clearer. Perhaps the dense nature, the strange acceleration, the lack of water. Perhaps these facts will become so solid, so undeniable, that the comet hypothesis finally and completely breaks. The truth will emerge. It always does. Because no one person, no one government owns the sky. The stars are a shared heritage. The light from 3i Atlas fell on everyone. And the data is in the hands of the people. This is the real power. Not the power of a government to classify, but the power of a global, curious human network to know. And so we can let go of the anxiety, we can let go of the inconvenience. We are not responsible for the answer. We are only responsible for asking the question. The truth about 3i Atlas is out there waiting in the noise of the data. And the combined power of all those curious minds, all those independent eyes, they will find it. We can close our eyes knowing that the watchmen are on the wall, the astronomers, the amateurs, the enthusiasts. They are all looking up. The sky is being watched. The data is being checked. And whatever the answer is, it will be shared. We can rest peacefully in the knowledge that the process of discovery, the slow, steady, and unstoppable march of human curiosity, is doing its work. The truth will be known. The final days of our collective wait are now counted not in months or weeks, but in single precious days. An invisible clock is ticking its soundless rhythm, echoing in astronomy departments, government offices, and quiet bedrooms across the globe. It is a quiet global countdown, a shared moment of anticipation as we stare at the approaching headlights of a train uncertain of what it carries. 2 dates are circled on the world's calendar, 2 moments where the great lens of the James Webb Space Telescope will pivot, focusing its immense power on our 2 mysteries. On November the 24th, its gaze will fall upon C225K1, the Golden Visitor. The campaign's goal is simple yet profound: to find the missing gas cloud that our models insist must be there. Just 2 days later, a pause for breath, and then, on November 27th, our attention pivots. The campaign for 3i Atlas begins a hunt for the same spectral evidence, the same telltale shimmer of hydrogen and helium that would explain its impossible brightening. These 2 days represent the hinge upon which our understanding may turn. We are standing at the threshold holding a key that fits 2 separate locks. Behind each door lies a different future, a different understanding of the cosmos. Humanity in this moment stands at a fork in the road. Down one path lies an answer that is familiar, comforting, and in its own way magnificent. The second path leads to a landscape we have never seen before, a place for which we have no maps. Let us walk down the first path, the scenario of a natural known universe. In this future, the 24th and 27th of November arrive. The data streams back from the Webb telescope, and the scientists poring over the spectra find it. It is faint, far fainter than any model predicted, perhaps composed of elements in a ratio we have never before seen. But it is there. A sparse, almost invisible halo of hydrogen and helium gas ejected by some unknown internal process surrounds C225K1. The brightening, the outgassing, the strange glow, all of it is explained. The object was simply a new class of comet, a celestial body far more complex and dynamic than we ever knew was possible. 2 days later, the same story unfolds for 3i Atlas. We find its cloud perhaps a different composition, but a cloud nonetheless. That strange acceleration. A pocket of denser gas invisible to our other instruments, giving the object a tiny unexpected push like a leaf caught in a sudden breeze. The metallic signature's dust, we conclude. Exotic dust grains of processed iron and aluminum, but still just dust forged in the heart of a long-dead star and trapped in ice for billions of years only to be released now. In this reality, we would feel a complex global sigh, a mix of profound relief and perhaps for some a faint unspoken disappointment. The aliens would vanish, retreating back into the realm of science fiction. But this supposed failure would be in itself a staggering scientific triumph. We would have discovered a new kind of cosmic object. We would learn that the universe in its endless ingenuity can create things that mimic intelligence, that can build with industrial metals and glow without sunlight all through the slow, patient hand of physics. We would learn that we are once again too quick to see our own reflection in the cosmic mirror. The universe is, as it has always been, stranger and more creative than our models. We would update our textbooks, our theories would expand, and our sense of solitude would be for a time reaffirmed. We would be alone, yes, but in a universe far more vibrant and surprising than we knew. Then there is the second path. In this scenario, the 24th of November comes. The data from C25K1 streams back. The scientists look, and there is nothing. No gas, no dust, no cloud. The spectrometers find only the hard, clean vacuum of empty space. The object is glowing, burning with the light of a small town, and there is no fuel. The laws of thermodynamics as we understand them are not just being bent, they are being shattered. A heavy thonce would fall. The world would wait, holding its breath for the 27th. Surely Atlas will be different. Surely K was the anomaly. The data from 3i Atlas arrives. And again, nothing. Absolutely nothing. No gas to explain its light. No exhaust to explain its acceleration. It is moving, steering and brightening by itself. In this scenario, the natural hypothesis does not just fail, it evaporates. We would be left naked with the objects themselves in all their impossible glory. We would be facing an object that brightens without fuel, an object that moves with controlled propulsion, an object that broadcasts the signature of refined industrial-grade alloys, an object in a purposeful non-gravitational orbit. This scenario is the one that hums with a quiet, terrifying and exhilarating potential. It is the sound of a door opening in a house we believed was empty. It would mean we are no longer just looking at a rock, a comet, or a natural phenomenon. We would be forced by the sheer weight of evidence to confront the fact that we are looking at a thing, an artifact, a signal, a presence. The implications are too vast to hold in a single thought. It is the single greatest discovery in human history, and it is a truth we are utterly unprepared for. But here is the truth that we can hold on to in these last few days of quiet. Whatever we find, whichever path opens before us, the legacy of these two visitors is already written. Their true gift was not the answer, but the question. For decades, our search for life beyond Earth has been a monologue. We have been shouting into a dark and silent jungle, listening only to the echo of our own voice. We sent out the Voyager record, a message in a bottle. We beam radio signals at the distant stars. We listen with our great radio telescopes, hoping to catch a single stray whisper. But the jungle has remained stubbornly, profoundly silent. These objects, Su-25, K1 and 3i Atlas, were the first time the jungle seemed to shout back. Regardless of their origin, they have already changed us. They forced a global collaboration on a scale we have not seen before, uniting telescopes and scientists from every nation. They forced us to dust off our most fundamental assumptions about the solar system. They forced us to look at our neighbour planets not as static orbs, but as destinations, as places of profound interest. We have always asked the question, are we alone? But it was a philosophical question, a late-night dormitory debate. These two objects forced us to ask, what if we are not? And more urgently, what if the answer arrives tomorrow? They have forced us to confront our own technological infancy, our own fragility, and our own profound shared isolation on this blue marble. That is their legacy. They woke us up from a long, comfortable sleep. This awakening brings with it a choice. It is the choice of how to be in this moment of waiting. Our history, the history of science, is built on a foundation of skepticism. It is our most important tool. We remember the LGM-1 signal, the little green men signal, which in 1967 turned out to be the first discovery of a pulsar, a rapidly sending neutron star, a natural wonder, not a message. We remember the Viking lander on Mars, which in 1976 found ambiguous chemical reactions in the soil reactions that were ultimately and heartbreakingly deemed non-biological. We remember Oumuamua, the first interstellar visitor which sped away before we could truly understand its strange tumbling acceleration. Skepticism is our anchor. It stops us from drifting into the alluring waters of fantasy. It is the barrier that protects the integrity of the scientific method. But an anchor held too tightly can also prevent a ship from ever leaving the harbour. There is a point where healthy skepticism can become a fortress, a high wall we build to protect ourselves from a truth that is simply too large, too strange, or too disruptive to accept. The choice then is to remain open, to be rigorously skeptical of the data, but also completely open to what that data is telling us, even if it leads us to a place we never ever expected to go. So as we wait for the final verdict from the Webb telescope, let us sit quietly and review the impossible facts one last time. Let us understand the weight of evidence that has brought us to this precipice. First, the brightening. Both objects, C225K1 and 3i Atlas, grew luminous, shining with a light that should not be possible without a vast surrounding cloud of gas and dust. Boom. We have looked. That cloud is not there. Second, the acceleration. 3i Atlas is not just moving, it is steering. It has altered its path, defying the simple, elegant pull of the sun's gravity. It is navigating. Third, the composition. The spectral signature of 3i Atlas is not ice. It is not rock. It is the unmistakable cold fingerprint of heavy processed metals, aluminum, titanium, and iron alloys. These are not the building blocks of comets. They are the building blocks of industry. Fourth, the orbits. They did not just fall into our solar system. Their paths are too precise, their arrival at Mars and Earth too coincidental. They arrived. Any one of these things by itself could be a statistical outlier, a once-in-a-billion-year fluke. But all four in two separate objects arriving at the same time. The natural hypothesis, the idea that these are comets, now asks us to believe in a chain of coincidences so long, so improbable, that it strains credulity to its breaking point. It asks us to believe in a magic trick performed by a nature we have never seen before. And so we find ourselves here in the quiet of the night waiting. If you look up at the dark expanse above, you cannot see them, not with your own eyes. They are too far too small, but they are there. One a shimmering impossible gold gliding past the orbit of Mars, the other a deep resonant blue falling toward Earth. Two travellers moving through the darkness. We do not know the answer. And for these last few nights, that state of not knowing is our shared reality. We are a world united for a brief moment, not by a border or a belief, but by a single cosmic question mark. We are a world holding its breath. We are a world that is finally listening. The waiting is almost over. The universe has sent us two messengers, two mysteries, two invitations, an invitation to wonder, an invitation to dream, and an invitation to question our true place in this vast, silent, and suddenly very, very active cosmos. The answers are coming whether we are ready for them or not, and all we can do as we drift off to sleep is wait and listen and rest.